So the first question, try to explain what is quantitative variable. So quantitative variable, just the numerical values. So the variable that represent the actual data, they want quantitative. Okay, so numerical data. Qualitative variable, so the one that we just discussed just now. So variable that we create to represent different categories they want. Qualitative variable. So dummy variable, just the variable that we create. So quite similar. So dummy variable is a variable we create to represent different categories. Question number 2. So A, consider the cross section regression given here. So we have dependent variable income, independent variable we have education and meal. So in this case, education is the percentages of schooling. So that one education. Income and education just the qualitative variable. So income is income. Education is percentages of schooling. So there's number in terms of number of years. So that one is the quantitative variable. Meal is the dummy variable. So M male is equal to 1 if the individual is male, 0 otherwise. Show how the intercept changes for male compared to female. So this one, because we have one dummy variable, so this dummy variable allows us to differentiate the two categories, male and female, in terms of intercept. Because if the variable equal to 1, then male has an additional part of intercept, beta 0 part beta 2. For the case of female, this one 0, then we only have this one. Okay, so you look at the given solution. So it's explained us for the case of the reduced equation for male as well as versus for female. So for male, we have this one. So we have intercept beta 0 plus beta 2. For the case of female, just beta 0 intercept. The slope are the same for both. The slope the same for both male and female. B. So for B, we have interaction between independent variable, education and male. To show how the slope coefficient for education differs for male compared to female. So this one, if male equal to 1, then we have intercept for male beta 0 by the slope. The slope because beta 1 education plus beta 2 education, because if this one equal to 1, so we have beta 1 plus beta 2 education. So we have the slope for the case of male, beta 1 plus beta 2. For the case of female, when male equal to 0, the variable equal to 0, so we have the intercept beta 0, slope beta 1. So the second equation only allows the model to differentiate the two categories, male and female, in terms of the slope. So now, if let's say you want to have a model that allows you to differentiate the two groups, male and female, to have different intercept and slope, what you need to do? So you need to have formula. You need to combine. So you need to add this one. This one you need to add. You need to add another interaction as beta 2 plus education and male. So this one only is a variable. So you need to add interaction so that the model allow you to have both to be different in the sentence, just like the example that we considered in the lecture just now. So question number 3, a large corporation firms hires financial advisors to work with clients by the not paid commissions. When someone you hire is very varied depending on different factors, the probability relation is used to estimate the relationship between slash paid and few key factors. So we have dependent variable salary. Independent variable we have experience. So salary is just by a quantitative variable. So annual salary. Experience years of experience. So that one. So this one just quantitative variable as well. So GPA grade point also quantitative variable. But we have two quantitative variables. So this one is two quantitative variables. CSP, which is equal to 1 if the individual is certified financial planner, if not 0. And then we have another variable NOCFP that is equal to 1 if the individual is not certified financial planner and 0 otherwise. So you can see that these variables are representing the same thing. Okay, redundant, just like male and female. Just like you create that variable for female and for male and another one for female. Okay, so basically you do not need to have both. So in this case, what problem that we have here, since we have beta 0 in the model, so the sum of these two will have all equal to 1, which is equivalent to this one. So we have perfect identity now. Okay. So you cannot include both. So number 3, this regression has fallen into dummy variable trap. CFP and NO, CFP have a perfect linear relationship because you take sum of the two variables equal to 1 no matter what. This violates the assumption that two independent variables can have perfectly linear relationship. So in this case, basically the sum of this equal to the first column. Remember in X matrix, the sum of these two equal to 1, which is equal to the first column in your X matrix, so that we have perfect collinearity. So the regression cannot be estimated. One of these should be excluded, should be left out for the regression, or if you want to retain both in the model, then you have to take out the normal intercept, beta 0. You have to exclude the beta 0. Okay. Number 4, consider the following time in the model which attempt to explain employment for construction workers. So we have 3 different models for us to choose. So the first one, we have an employment data dependent variable. Independent variable, we have GDP, and then we also have dummy variables that represent different seasons. So we have summer, winter, fall, spring. So for this one, if the data belong, data belong for the summer season, this one equal to 1. If not, this one equal to 0 lah. If data belong to winter, collected during winter, for example, or representing data for winter, then this variable equal to 1, if not equal to 0. So meaning that for each of the observation, only one of these must be equal to 1, and the other 3 must be 0. Okay. So we have summer 4 seasons. So you can create up to 4 dummy variable for each of the seasons. But since we have beta 0, here, the common intercept, if we include that variable for all categories, then we have the same problem like before. Sum of this, summer plus this, winter plus fall plus spring, all into 1, which is equal to the first column in your X matrix. Okay, so we have the first model cannot be used because it has fallen into dummy variable trap. So one variable must be omitted or excluded from calculation. Second one, we exclude spring, so we only include 3. Then okay, because we have beta 0, then we have only 3. The third one we don't have in the set. We exclude 1, but we don't have the beta 0. Then meaning that the model is incomplete because we don't have. Remember, for the second one, beta 0, the common intercept represent for the one that we exclude. So beta 0 is our reference category, represent for the reference category, which is for spring. For the second model, spring is our reference category. So that is represented by beta 0. So for the model number 3, we don't have reference category. So we don't have coefficient to represent the reference category, beta 0. So model number 3 is incomplete. It's not complete. So we need the model we should use the number, model number 2. Okay. So why did you reject the 2? Because so I explained before, the first one that you are reject, the last one is it's not complete and incomplete. How you tell the habitability that in general the season of the year does not affect employment? So using the second model, how to test? Because remember, for the spring intercept beta 0, for summer intercept beta 0 plus beta 2, for winter intercept beta 0 plus beta 3, for intercept beta 0 plus beta 4. So you need to test whether beta 2, beta 3, beta 4 all equal to 0. Okay, not equal but equal to 0. Beta 2, beta 3, because for the case of spring, they intercept beta 0. So this model only allows the intercept to be different. but it does not allow the slope to be different. If you want to have the slope to be different, you need to have interaction, but now you have many other variables, so also it might be difficult to do. So if you want to perform the test, then you have to tell that one. You perform using the walk test. The walk test. Question number 5. The following table gives non-seasonally adjusted quarterly data on the retail sale of apparel and accessories for the period of 1993 to 1986. So we have quarterly data. So now it just like we have different categories. We have 4 different categories. So we have just like season just now. Right now we have different quarters, 4 different quarters. So it's just like 4 different. So we want to know how different quarter affect the sales. Then you need to create that variable to present different quarter. Okay. So consider the flow model. You create a variable sales of this, and then you create that variable for second quarter. You include that variable for second quarter, third quarter, and last quarter. You exclude the first quarter. Okay. So meaning that the first quarter is represented by beta 0. The intercept, the sales, the estimate of sales for first quarter is given or represented by beta 0. And then for the other quarter, for the second quarter, the sales estimate of sales is given by beta 0 plus beta 1. You understand, right? So second quarter beta 0 plus beta 1, quarter beta 0 plus beta 2, the last quarter beta 0 plus beta 3. The intercept, so this one we only consider the intercept to be different across the 4 different quarters. So estimate the model. So what is the interpretation of the bias coefficient? So you have the data. So this one we have the quarterly data, still data. So in order to investigate, to examine the effects of different quarter on sales, we need to create that variable first. Okay. So how to create that variable? For the time series data like this, for quarterly data, you can create a variable using the NSEAS. Okay, for example, this one. Now we want to create that variable. Let's say D1 for the first quarter, D2 for the second quarter, D3 for the third quarter, D4 for the last quarter. So you go to quick generate series. Quick generate series, and then you put D1 equal to NSEAS bracket 1. Okay, I show you this one. So D1 equal to this. And then after that, you create another variable, D2 equal to this. So if for the case of, because this our data is quarterly data, so if we create that variable for different quarters. So D1 for first quarter, D2 for second quarter. If your data is monthly data, then if we create that variable for different months. So you use the same command, but it is produce dummy variable for January, February. So you need to put 1, 2, 3 until 12. For this case, until 4, because we have 4 quarters. Yeah. So this one, okay. You see that we have only 1 for the first quarter, 0 for the rest, and then we do the same again, repeat. So we put D2 bracket 2. Then be careful, you put this one correct value, then you get correct one. Okay. So D2 only one for second quarter, 0 for the rest. Then you again. D3 and then D4 bracket 4. the estimate model, quick estimate equation. So we have sales, our dependent variable. And then question asks us to have the common intercept, which is beta 0. So we put C for beta 0, common intercept. And then we have, we don't have other variable, we only have the W variable. So we have D2 space D3 D4. So we exclude D1 because if you put all, what happen? You put C and you put D1, D2, you put all, what happen? You have the perfect collinearity lah. So you cannot include all the variables. You have to exclude one. So that the first quarter is your reference category. Okay, so press OK, so you get this one. So now, how to interpret? You have to understand how to interpret. So C is your intercept for the reference category. So it will give you an estimate of sales for the first quarter. How about this one, D2? D2 gives you additional part of the intercept. It does not represent the whole intercept for the second quarter, but it just the additional part of intercept. So to get the whole intercept, for second quarter, you must add this one, beta 0 plus beta 0 plus beta 1. Okay. So you understand this one, you use this equation, you use formula, you use this model. The first quarter is given by this one. The estimate of sales for first quarter is given by this. So second quarter, beta 0 plus beta 1. Second quarter, beta 0 plus beta 1. Third quarter, beta 0 plus beta 3. So you have to add. So for the third quarter, this one plus this. The last quarter, this one plus this. Okay, to get the sales. So this allows you to test whether the difference is significant or not. There is significant difference, okay, between the reference category and each of the quarter. So what is the interpretation of the various coefficient? So the average sales in the first quarter, 4,768 million. In the second quarter, it was higher by about, because again, so the value given here represent the additional, not the whole sales estimate for the second quarter, just additional. So you say that higher by this. Okay, as compared to reference category. This is our reference category as compared to reference category. This one, because second quarter, this one plus this one, then this represent the additional part. So higher by about 912 million. In the third quarter, by about this. The second quarter, the last quarter is about by this. Okay. And the actual values of the intercept in the various quarters can be obtained by adding the differential intercept. Dummies to the base quarter value. The individual intercept values are respectively as given here. So this is the first quarter, second quarter, this one plus this one, you get this. For the third quarter, this plus this, you get this. Okay, the last quarter, this plus this, you get this. So for this model, how to perform the test in order to say, so they say you are asked to test whether there is significant difference. There is significant difference in the sales for the 4 different quarters. So you need to test this one, you need to test beta 1, beta 2, beta 3, whether all equal to 0 or at least one of them not equal to 0. Understand? So you need to test this one, beta 1, beta 2, beta 3. You can perform the one test as usual. So So if you reject, meaning that sales are not the same for different quarters. If you do not reject, all equal to 0, then you can conclude that sales are just the same for the four quarters. Understand? So again, this one, you need to test this equal to 0. So you go question number 2, 3, 4. Walk test, coefficient statistic walk test. Option number 2. Three and 4 all equal to 0. If we do not reject, then we say that sales are just the same, which is given by the reference category 4767. If we reject, means at least one, because the coefficient, the additional part, the differential, estimate of the differential sales, if any of them, if we reject, meaning that there is a significant difference now. Okay, so you see the test statistic and p-value, so we reject now, meaning that the sales are not the same. The sales are not the same for the 4 quarters. At least there are 2 quarters that have different value of sales. Okay, the actual value. What we have estimate, I hope you understand, huh? I hope I hope you understand. What we have here is estimate, but you want to perform our testing to make inference or conclusion about the true value. Okay, the true value, because this is a sample, we want to make a conclusion or statement about the population one. Okay, that's through the hypothesis testing. Whether we are confident enough to say the true sales, the actual sales, equal or not equal for 4 different quarters. You look at the numbers, there are difference. But this one is estimate. This one what we have is just estimate for one sample. Yeah. Question number 6. So you use the same data, but now you include all dummies for all categories. So meaning that you can include dummy for all categories, but you have to take out the set. You have to remove the common intercept beta 0. Yeah. So this one, let's say we this one I want to show you the alternative way of estimation. Okay. If let's say you don't want to create that variable first, let's say you have, for example, let's say you have weekly data, so you have 52 categories. Okay, 52 categories, and then for weekly, not sure whether we can do it, but for monthly data you can use. So this one, let's say there's an alternative way to estimate this one. How? You can, instead of creating manual variable first, you can directly estimate the model by using this command. Okay, so this one, instead of creating manual variable first, you can just directly estimate this model. So instead of put D1, D2, D2, D3, D4, you can put and expand at quarter, but because if you do this, it will create a variable for all categories. So we need to exclude one because we have C here. Since we have common intercept beta 0, then we need to exclude one of the dummy. How to exclude one of the dummy? You need to add drop first. So you put drop first, you will exclude the first dummy, the first category. If you put drop last, you will exclude the last category. So you only have 2 options. So you have 4 quarters. Either you drop the first quarter, or you drop the last quarter. So you want to drop the last, we put drop last. Okay. So this alternative instead of alternative to this one. Just now we use this. You put C, we put D1, D2, D3, D4. But we need to create this one variable first. We need to generate this variable first. But alternatively, you do not need to create a variable first. You can just directly estimate model by using this command. Okay, expand quarter, drop first because we don't want D1. We don't want to D1, so we drop the first to D1. Okay. So we estimate, so this one drop first. So we get the same estimate. Okay, we will get the same, but the benefit of doing this is that you do not need to create that variable first. Yeah, you can just directly. If you have monthly data, instead of put quarter, you put month, MONTH. Okay. If your data is monthly, then you put, instead of quarter, you put MOT, month, MONTH. Okay. Okay, now question number 6. Question number 6. So now question number 6 asks us to include W for all categories, but we need to exclude the common intercept without 0. So you have to estimate model. So quick estimate equation. So we have sales. And then without C, and then you can include all. So question number 6. Question number 6. So it's sales without C because C for the beta 0. And then expand, so meaning that you will have W for all quarter. Okay, without the common intercept C. So basically, okay, you can include W for all categories, you can, but you have to exclude the common intercept. Okay, beta 0. Otherwise, because remember your X matrix, we don't want to have. You include all that variable, then you have to make sure that the first column is not all equal to 1. So this one, okay, name equation, the previous one, equation 1, second one, equation 2, okay lah. So you compare, so this is equation 1, this is equation 2, equation 1, equation 2. So you see the difference when we estimate the second model. So each of these represent estimate of sales for each quarter. There is no reference category anymore. Okay, there is no reference category anymore. So each of these provide estimate of sales for each of the particular quarter. So this one, beta 1 is the estimate of sales for the first quarter, beta 2 estimate of sales for the second quarter, and so on. So you can see this one. The first quarter 4767, just like before. Okay. Second quarter, so this one equivalent to this plus this 4767 plus 900 something, you get direct estimate. Okay, direct estimate. So how you interpret? So as a given here, so basically this model have a sign. We have assigned a non-variable for each quarter, but until that to avoid the variable trap, we omitted the intercept term for this model. So the second, so B, to estimate the model, we have run a regression through the origin, so meaning that we exclude the beta 0, so yes. Then compare the result from the model with the previous one. So if you compare, this second model gives us direct estimate of the sales for each quarter, not only the differential. Okay. So it gives us the direct estimate of the sale. So it depends on what you want to perform or what test you want to perform. If you want to compare, if let's say your objective, you want to compare whether the sales of the second quarter significantly different from the reference category, then you have to use this one. You have to use the first model. But if you just want to test if the sales are the same or not for the 4 different quarters, you can use this one as well. So if you want to test, if let's say you want to perform a test whether the sales are the same or not for the by whether it's affected by different quarter. So you can perform the walk test as well, but in this case, you perform the test that option number 1, 2, 3, 4, all equal, not equal to 0, but all equal only. Okay. This one you just test whether beta 1 equal beta 2, equal beta 3, equal beta 4 or not. Not equal to 0, but equal only. Okay, for this model, second model. So if you perform a test, you go to walk test, coefficient elastic, walk test, you test coefficient number 1, 2, 3, 4 equal. Okay, not equal to 0 but equal. So okay, so you get the same one, just like the same result like before. The same, exactly the same. So p value greater smaller than 0.05, so conclude that the sales are not the same. So meaning that it is affected by different quarters. Different quarters have different sales. So in terms of comparison, so as I explained here, so we provide a direct intercept values for each of the quarter. The previous question, question number 5, intercept values for second, third, and fourth quarter are obtained by adding the patient itself. So of course, the procedure give identical result as they should. This data, if you check in detail, so you produce graph of the series, you can see that basically it has trend. So basically the better models that you should include trend as well. Okay. You can see the values of series increase. So the better model, I mean, it's not even in the question. So, but if you want to have a better model, then you have to include trend as well. So if you estimate the model, where is the D1? D2. So we estimate model by adding trend as well. Or maybe it can be done either one. You can using the based on question, even question number 5 or number 6, either one. So trend, I'm not sure whether I explained to you before. For the trend, just add trend plus 1. Yeah. So either one lah. So let's say whether this but this one you have to put at trend plus 1. So either use one or this one, either one lah. Yeah. So let's say you add trend for the second one, so you get this lah. So trend significant, so you have better model. So you compare maybe your IC or just the aspect vector. So one of the question just like your midterm test question, how to know the first part, which one better? Question number A, 1A or the last one, not the last model. When we exclude, so which one better? You can refer to the adjusted square. Which one has higher value of adjusted square? That's how you should answer the question. As we. So we have half an hour minutes left. Should we discuss the answer for the test, or you want to stop the lecture now? Why? So you're not confident you answer it correctly. Okay, so we start now. About next week.